Chapter 4 begins our chapters of trigonometry for pre-calc. So section 1 should be somewhat a review from the trigonometry that you learned last year in Algebra 2 Trig. First, we're going to talk about angles in standard position. So when we think about an angle in standard position, we think about the four quadrants, and we think about this axis, the x-axis, the positive axis, being at 0 degrees. And we think about the positive y-axis being at 90 degrees. And if we go halfway around the graph, kind of like we're moving in a circular motion, we'd be at 180 degrees. And then we'd be down at 270. And if we come all the way back around, we've made it to 360 degrees. So these are the degree measures of kind of the four quadrants that would break up a circle if we are traveling in a circular motion. And if we are traveling counterclockwise, all of our angles are positive. However, if we travel clockwise, our angles start to become negative, or we represent them as a negative angle. So, for example, 270 can also be represented as negative 90 degrees if I start from 0 and I travel clockwise. So, an angle in standard position always has its initial side on the positive x-axis, so at 0 degrees. And then its terminal side would be anywhere else along the, in the circle. So if I put the angle's terminal side right there, this would be our angle measure in between 0 degrees and wherever that angle ended up. To me, maybe it looks like it's at about, 120 degrees. And then we call the angle theta. So theta is always what we use for an unknown angle, kind of like x is what we use for an unknown value. So that would be what a picture would look like if we are looking at an angle in degree measure. Last year, you also learned about radian measures. And radian measures come from the circumference of a circle. So if we start at 0 radians and we go all the way around the circle, we end up at 2 pi. Because to find the circumference of a circle, we do 2 pi r. So we take whatever the radius is, and we move it all the way around, and that would be 2 pi. Erase that guy. Okay, so let's list the rest of our radian measures. So if we go halfway around the circle, we would be at pi radians, because all the way around is 2 pi. If we go halfway between 0 and pi, we would be up at pi over 2. So pi over 2 radians corresponds to 90 degrees. And then if we go halfway between pi and 2 pi, you can kind of think about it as we're at 1.5 pi's, which would be 3 pi over 2 as a fraction. And so radian measures work the exact same as degree measures. Our initial side is always on the positive x-axis, and then our angle will end up somewhere else. So let's put them here for this picture for funsies. And so our angle will start at the initial side and come around to the terminal side, and that would be our angle theta. And just like degree measures, if we move around the circle clockwise instead of counterclockwise, our radian measures are negative. So 3 pi over 2 would be the same as negative pi over 2. Now there is one more way to think about angles and their measures, and we'll talk more about this later, but we want to also know what the decimal values are of our radian measures, because sometimes we'll see an angle and its measure will be 2.4, and that's not in degrees, that's in radians. So what we kind of want to think about is that 0 radians would just be the same as 0 in decimals. We know that pi is equal to 3.14 about. So 3.14 would be what our measure is, our decimal measure for pi radians. And then half of 3.14 is about 1.57. So that would be the measure for pi over 2. And then to get the next one, you can just add them up. So if we add those up, let's see, 4 plus 7 is 1. So that would be 4.71. So 4.71 would be the decimal that approximately matches with 3 pi over 2. And then, scooch this over a bit. For 2 pi, that would be about 6.28. And so then again, we would just have our angle starting on the initial side and ending, and then our theta would start at the initial side and go all the way around to our angle. So I don't know, maybe that angle measure would be something like 5.2. Just taking a guess, I'm not sure. But those are the different ways that we can measure angles. We have degree measurements, radians, and then decimal radians. So as I said before, going counterclockwise around a circle gives us positive angle measurements, and going counterclockwise gives us negative measurements. So what I would like you to do is pause the video and try to draw the angles below in standard position. So I labeled all of the quadrant angles. That's whenever you have an angle on a quadrant. So 240 degrees would be about 30 degrees away from 270, or 60 degrees past 180. So if we drew our angle about right there, that would look pretty good. You don't always need to draw the initial side. In fact, we don't draw our initial side very often. But our angle would start from 0 and come all the way around, and this would be our angle theta. If you just drew the terminal side of your angle, that's good enough. I don't need to see the theta. So we'll do that for 500 degrees. So for 500, if we start at 0 and go all the way around, we're already at 360. So for 500 degrees, we need to keep going another 140 degrees. So if we go another 140 degrees, we'll be 50 degrees past 90. So a little bit more than halfway. So this would be a 500 degree angle. And you can just leave your angle looking like that. You don't have to draw the theta. And then for negative 50, this time we want to move in a clockwise direction. So if I start at 0 and go towards negative 90, I would just be a little bit past halfway. So there would be my angle for negative 50 degrees. So if we look at part B, we noticed that we had to go all the way around the circle to past 360, and then we had to go 140 degrees more. So it looks like that 500 degrees and 140 degrees ended up in this exact same location. And they do, because they are actually coterminal angles. So since a circle is 360 degrees, we can add or subtract that number to find coterminal angles. And sometimes it's easier to find a coterminal angle before you draw it. So for number 4, we want to find one positive and one negative coterminal angle. So for negative 45, to find a positive coterminal angle, I can just add 360 to that, and I would get 315. So if I drew the angle negative 45 degrees and I drew the angle 315, they should end up in the same spot. To get a negative coterminal angle, I can just subtract 360, and that would give me a negative 405. So negative 405 degrees if I went in the negative direction around my circle, and I had to pass negative 360 and then keep going, I should end up at negative 405. For part B, to get a positive coterminal angle, we could add 360, but we'll get a pretty gigantic number. It would probably be easiest to just subtract 360 because we'll still get a positive coterminal angle. So if I subtract 360, I am going to get 35 degrees. So 395 and 35 degrees would end up in the exact same spot. And then to get a negative coterminal angle, I can subtract 360 again, because that just means I'm going around the circle one more time in the negative direction. So I would get negative 325. So 35 degrees and negative 325 degrees and 395 would all be coterminal angles. For part C, we can definitely subtract 360 to get a coterminal angle. So we'll do a little bit of borrowing here. So we get 14 minus 6, which is 8. So 380. So we get that 380 is a coterminal angle, and he's a positive one. So then to get a negative one, we can subtract 360 again. But when I do that, I get the angle of 20 degrees, which is still a positive coterminal angle. So we've actually found 2 positive coterminal angles now. So I'm going to subtract 360 one more time and get a negative 340. So I can use negative 340 as my negative coterminal angle, and I could use 20 degrees as my positive coterminal angle, or it wouldn't be wrong to use 380 degrees as a positive coterminal angle. So as long as you're adding or subtracting 360 degrees, you'll always have a coterminal angle. So now we're going to switch gears and talk a little bit about radian measure. So a radian is a measure of an angle in regards to, as I said earlier, the circumference of the circle. To convert between degrees and radians, we multiply by pi over 180 in order to convert degrees to radians. And to convert radians to degrees, we multiply by 180 over pi. So next we're going to use those conversion formulas to help us convert between degrees and radians. So I start out with 125 degrees, and I want to know what is 125 degrees in radians. So I'm going to multiply by pi over 180. And I want to reduce my fraction to the simplest form. So I know that both, or 5 goes into both 125 and 180. So 5 goes into 125 25 times. So we have 25 pi over. And 5 goes into 180 36. And we can't reduce it any further, so it would be 25 pi over 36 radians. So now we want to take negative pi over 12 and convert that to degrees. So this time I'm going to multiply by 180 over pi. And here our pi's will cancel, which is good because we don't want pi's in a degree measure. I mean, it can happen, but usually the pi's should cancel out. And 12 goes into 180 15 times. So we're just left with a negative 15 degrees. So we already discussed that if we go all the way around the circle, instead of it being 360 degrees, we could say that that is 2 pi radians. So if we switch gears and we're talking about coterminal angles in radians, instead of adding or subtracting 360, we can add or subtract 2 pi. So if I want to find one positive and one negative coterminal angle to 3 pi over 4, I don't have to convert 3 pi over 4 to degrees and then add 360 and then convert it again. That's too much work. All I have to do is add 2 pi to get a positive coterminal angle. The only thing with these is that we're dealing with fractions, so we just need to get some common denominators. So we will have a positive coterminal angle at 11 pi over 4. And then to get a negative coterminal angle, I can just subtract 2 pi or 8 pi over 4, same thing. And I'll get negative 5 pi over 4 as my negative coterminal angle. So why don't we pause the video and you guys can try B and C, finding one positive and one negative coterminal angle in radians. So for B, we should have first subtracted 2 pi, because if we would have subtracted 2 pi is 12 pi over 6, we still would have gotten a positive coterminal angle. So if we subtract 12 pi over 6, we get pi over 6. And then we can take pi over 6 and subtract 2 pi again, which is the same as 12 pi over 6, and get negative 11 pi over 6. And for part C, if we add 2 pi or add 6 pi over 3, we get 4 pi over 3 as a positive coterminal angle. And if we subtract, we get negative 8 pi over 3 as a negative coterminal angle. So down on the bottom, we already talked about what radians are in decimals. So we can think about pi radians as 3.14 radians and 2 pi radians as 6.28 radians. So for the next set of problems, I would like you guys to use your calculator to convert the following radians into decimal radians. And all it simply is typing 3 pi divided by 4 into your calculator. So why don't we pause the video and then we can restart it and you can check your answers. So hopefully you got the decimals above. So now for the next question, we want to sketch each angle in standard position, but we want to try to sketch it without trying to convert it to a degree first. And just knowing where it would be on the, or which quadrant it would be in, just knowing the measurements of each quadrant angle in radians or decimal radians. So if we take a look at negative pi over 12, I already drew the x and y axis, and I drew it using negative radian measures since we want to try to sketch a negative radian measure. So I started with 0 and then I went clockwise, so I have a negative pi over 2, a negative pi, and a negative 3 pi over 2. So you kind of want to think about this as fractions, and negative pi over 12 is definitely less than pi over 2. 1/12 is less than 1/2. And 1/12 is a pretty small fraction, pretty close to 0. So I would sketch that angle about right here, coming from the origin. For part B, we want to sketch the angle 3.5, and we know it's not a degree because there's no degree symbol. So if there's no degree symbol, we always have a radian. So I labeled my x and y axis using decimal radians, so I can have an easier time sketching 3.5 or finding where it is. So I started at 0, 1.57, 3.14. So 3.5 would be less than halfway, but probably about right there. Pretty close. For part C, we're given -1, and there's no degree symbol. So we want to use decimal radians. And I am going to go clockwise and use some negative radians. So I'm going to start at 0. And then down here is -1.57, -3.14, and -4.71. And then I know that -1 would definitely be before -1.57. So maybe about right here would be -1. For D, I want to sketch 11 pi over 6. So when I sketch my angles, oops, that line is pretty crooked. Let's try it again. So when I sketch my angles, I want to use the regular radian measures. So I'll have 0, pi over 2, pi, 3 pi over 2, and all the way back around to 2 pi. And now I want to think where 11 pi over 6 would be. So it's definitely more than pi, because pi would be 6 pi over 6. And actually, it's almost 2 pi, because 2 pi would be 12 pi over 6. So I'm going to be pretty close to 2 pi, about right there. And for my last one, -7 pi over 4, I'm going to do radians, but the negative version. So I'm going to start at 0, -pi over 2, -pi, -3 pi over 2, and then -2 pi. And for -7 pi over 4, again, if I had 8 pi over 4, I would be at -2 pi. So it's going to be pretty close. And it's actually going to be right in the middle of the first quadrant. Since this is a pi over 2, this going right in the middle would give you a pi over 4. So that would be where -7 pi over 4 is. There is actually one more way that angles can be measured, and this is used in navigation, and it's another way to represent a degree if there is a decimal with it, and that is with degrees, minutes, and seconds. So if we want to know at 75 degrees, 32 minutes, and 55 seconds really is as a decimal, there's 2 ways to do it using our calculator. I'm going to show you the way that I can explain easily over the video, and then when I come back, I'll show you the shortcut on the graphing calculator. But you'll just have to use the long way until I show you. So to convert this to a decimal, we have 75 plus, since there are 60 minutes in an hour, we have 32 divided by 60, and in an hour you have to ask yourself how many seconds are there. So if there's 60 seconds in a minute and 60 minutes in an hour, we have 3,600 seconds in an hour. So this is what decimal they're really talking about. And then we can just plug that into our calculator to get our decimal answer for the degree. So putting that in the calculator, we have to round a little bit, but we get 75.5486. Now, there was one section that I forgot to add into these notes, but hopefully it is a review for you, and you can just add it in to your notes right here. So what I forgot to talk about earlier were complementary and supplementary angles. So you guys have been working with these ever since geometry. So two complementary angles would add to 90 degrees. If we're working with angles that are measured in degrees, if we're working with angles that are measured in radians, they would add up to pi over 2 or 1.57 if we're in decimal radians. And supplementary angles would add to either 180 degrees or pi or 3.14 if we are in decimal radians. If I have an angle that's over 90 degrees, it would not have a complementary angle. And if I have an angle that's over 180, it would not have a supplementary angle. And both angles have to be positive. This only works for positive angles. So, can you find, we'll just have to make a little spot for this special problem. Can you find a complementary angle to pi over 3? And why don't you find a supplementary one too for funsies? So find a complementary angle and a supplementary angle to pi over 3. And we'll pause the video to let you work. So to find our complementary angle, we want to say pi over 2 minus pi over 3, which is a little bit tough because if we want to do that, we're going to need to get some common denominators. So we'll multiply the top by 3 and the bottom by 3, and then the top by 2 and the bottom by 2. So our complementary angle would be pi over 6. And then for our supplementary, we want to do pi minus pi over 3, and our supplementary angle would be 2 pi over 3. The last topic we're going to talk about for this section is finding the arc length of a sector and also the area of a sector. So now when we think about a sector, you want to think about a pizza and then the pizza slice being a sector. So it's just a chunk of the circle. So the way that we want to think about arc length is we take a radius, and we're going to take that radius and we're going to rotate it across a certain area. So to find that arc length, we're going to use the formula that S stands for arc length, equals the radius times theta. But theta has to be in radians, since radians is part of the circumference of the circle. So if they give you an angle in degrees, we have to change it to radians. And also we want this central angle. So you'll remember from geometry what the central angle looks like. The formula for the area of a sector, since our sector is just a chunk of our circle, the formula looks the same in a way where we have an r squared. And usually to find the area of a circle, we have a pi r squared. But what we're going to do is we're going to take our angle theta in radians, which should already have a pi in it, and divide that by 2. So the the formula for the area of a sector is theta over 2 r squared. So if a circle has a radius of 4 inches, find the length of the arc intercepted by a central angle of 240 degrees, and then find the area of the sector. So let's draw a little picture of what's going on first. So here we have a circle with a center, and then we have a central angle of 240 degrees with a radius of 4 inches. So let's draw a radius of 4 inches, and 240 degrees is definitely more than 180. not all the way down to 170, so like maybe about right here. So we'll put our end of our sector right there. So we're going to have a pretty big arc length. It goes all the way around. And my theta goes all the way around like that. So a big central angle. So to find the length of the arc length S, we're going to use S equals R theta. And we know that R is 4. However, we don't want to plug 240 degrees in for theta because it needs to be in radians. So I'm going to take 240 and I'm going to multiply it by pi over 180 to convert it to a radian measure. So let's see, I know that 6 goes into 240 and 180, so it goes in here 40 times. And we can cross out the zeros, and it goes in here 3 times. So this would be 4 pi over 3. And then we just can multiply those together and get 16 pi over 3. And we'll just leave it in terms of pi, and that would be in inches. You could always put that in your calculator and get the decimal answer. So now we're going to find the area. So the area equals theta, which is 4 pi over 3 divided by 2. But let's do this. Let's do 1/2 times 4 pi over 3. That would be a little bit easier. Times my radius squared. So that would give me a 6 on the bottom. So 4 pi over 6 times a 16. So we'll reduce that a little bit. So that'll be a 3, and that will be an 8. So that will be a 32 pi over 3 inches squared, since we're working with area. And you can leave it in terms of pi, or you can type that into your calculator and get the answer. All right, so that is it for the section 4.1 notes.